Okay, so we went over vocabulary for the fill-in notes, and I showed you an example of a monohybrid cross, or just a regular Punnett square. Now I'm going to do an example with you with a dihybrid square, a bit more complex. So it'll take a little bit, but that's okay. So a dihybrid square, remember, is looking at two traits at the exact same time, and we're going to work with 16 squares rather than 4 squares. So I have an example here we're going to work through, and it's with pea plants, and pea plants are just kind of easy to work with as far as kind of keeping up with the flow and the same examples with what we're doing. So we have pea plants. All right, so when we are looking at using a dihybrid, let me get my pen and try to draw. We can go ahead and set up our square. Our horrible, horrible square. I'm going to make 16 squares, so I'm going to do 1, 2. Do make it big enough to where what you're writing in here you can actually read. Oof. You're doing a great job with straight lines. Okay. Much better. Okay, so with this pea plant, we're going to be looking at how tall or short a pea plant is. And we're going to be looking at, are the seeds yellow or green? Okay, so here are the alleles that we're going to use. Big T for tall. That looks like a great big T. Little t for short. So that's one of the characteristics we're going to look at, tall versus short. The second characteristic we're going to look at is yellow and green. Now, yellow and green, we're going to use one letter. We can't use Y and G. Okay, we got to pick one letter and stick with it. We use a capital and the lowercase. So with this particular example, note big T is the dominant. Little t is the recessive, so tall versus short. In this particular example, we're going to say yellow is dominant to green, and we're going to use Y. When we use letters that may or may not be difficult to decipher, whether they're capital or lowercase to you, just make sure that you do something kind of extravagant to one or the other so you know whether it's your capital or it's your lowercase letter. Because my big Y kind of could look like a little y if I wrote it the same way, which I kind of do. So I'll make it look different. So big Y here is going to stand for yellow. So we're going to do yellow is going to be dominant over green. So a little y, note how I did my Y, is going to be for green. All right, are we good? So 2 traits. We're going to look at color, and we're going to look at whether something is tall or short. So in this particular example, it says that to draw a complete dihybrid Punnett square for 2 parent plants that are heterozygous, tall, and yellow. So heterozygous means different. So different for height and different for color. So heterozygous tall and heterozygous yellow. And so how we put these alleles together to figure out what we are going to have as a parent, we're going to keep the characteristics separate. So I'm going to put the tall stuff together, and I'm going to put the color stuff together, all in one big slew. So it says, let me write this out. It wants both parents. So both parents are going to be heterozygous. So I'm just going to write, I'm going to write hetero in like 2 seconds. Hold on, let me change the size of that. All right, I'll go back to my pen. All right, so we're going to go hetero, tall, and yellow. That's what both parents are. So how does that look? If I'm hetero tall, then what am I going to look like as far as alleles? What's my genotype going to be? if I am hetero for tall, so for different for tall, I'm going to have a big T and a little t. Okay? And then if I have hetero for yellow, I've got different for yellow, I'm going to have a big Y and a little y. Big Y and a little y. Okay? That is my genotype for this parent. Both parents are hetero for tall and hetero for yellow, so I have a big T, little t, and a big Y, little y. Okay? Now, we have to figure out what goes here, 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 as well as what goes here, 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 and here, so that we can do this beautiful cross in the middle. So what we're going to do is kind of do like a cross multiply like you would in math to figure out the different combinations of T's and Y's that you need to be able to fill in what the mom is going to be and what the dad is going to be. So the way I do this is I take my big T, my little t, and my big Y, and my little y, and I'm going to go, all right, that T goes to that Y, that T goes to there, and then, so that's going to give me big T to big Y. That's going to give me a big T to a little y, and then I'm going to go that T to that Y, and that T to that Y. So I have a little t to a big Y, and have a little t to a little y. Okay, so note that you're probably saying, but this here is a capital Y, and you told us to keep our capitals before our lowercase letters, which is true. In this particular example, the way that we fill these in, we need to keep T's together and Y's together because it's easier for us to read. There's going to be a lot going on in these squares, and when there's a lot going on, we have to be able to tell pretty quick what's a T, what's a Y, and what is the arrangement of those. And so I wrote all my T's first, and then I wrote all my Y's second. And so keep it in that order. And because T's come first before Y's, I've kept that way. So that when we fill that in, all of this is going to work out in the end. But that's kind of how I do it to keep it straight. So these are the allelic possibilities for this parent to pass on through sperm or through eggs. Now notice that both parents are the same. So I'm going to take these letters and I'm going to put them on the side also because the both parents are the same, so I'm just going to use the same thing. So big T, big Y, big T, little y, little t, big Y, little t, little y. Okay? You fill in these just like you would a regular Punnett square, but with a little organization. You need to keep your T's together, you need to keep your Y's together, so it's easy for you to decipher the information afterwards. So, I go big T, big T, big Y, big Y, big T, big T, big Y, little y, big T, little t, big Y, big Y, big T, little t, big Y, little y, and you just keep going. So give me just a minute to fill these out. Notice how I'm keeping capitals in front and the lowercase. I'm keeping my T's together and my Y's together because it'll be much easier to read when you're asked a whole bunch of questions. Let's see. Okay, so everybody's filled out, not too shabby. So, like I said, there's a lot going on here, and you need to have a bit of organization about yourself in order to keep all this together. So, the first thing that could be asked is, what are all the possible phenotypes? What are all the possible genotypes? And ratios, and so percentages of those. So, if you look here, you have characteristics of tall and yellow. You can have tall and green. You can have short and yellow. You can have tall and green. So there's a whole slew of things that are going on here. So what I want you to do is figure out how many, so what is the percentage of tall, so phenotypes, tall and yellow. What is the percentage of tall and green? What is the percentage of short and yellow? And what is the percentage of short and green? All right, do that. I'm going, if you will, email me or post on Canvas since you're already in Canvas. If you'll post in Canvas to me a message of what is your percentage in this dihybrid of these different phenotypes. Note that in order to get a percentage, it's simple math. This particular square is 25%, so like all that 25, 25, 25, 25, all this is 100 added up. So if you have 1 out of 16, put that into a percent. If you have like 4 out of 16, that's 25. So simple percentages. Email me your answer to this down here. What is the percentage of tall and yellow? Percentage tall and green, short and yellow, short and green. And email that to me or post that through me to me on Canvas.